Hi everyone, so today we'll be going through the basic static analysis for the malware Lucky Cat. So basic static analysis is actually one of the 4 analysis methods that can be used to investigate a malware. However, basic static analysis is the analysis technique that actually focuses on using automated tools to analyze the malware source code and also to see what the malware has in store. And these automated tools actually give a pretty good starting point for understanding the functionalities and characteristics of a malware. So for basic static analysis, this time we'll be using WinMD5, PEID, PEView, Dependency Walker, and bintex. However, before we start basic static analysis, I'd like to do one thing that's extremely important and vital step before any sort of analysis should be done, which is malware fingerprinting. So what this malware fingerprinting does is actually to identify and classify a malware based on its specific characteristics or attributes to, let's say, a malware sample. So actually, although there are many methods also in malware fingerprinting, the method that was used in this time's analysis is signature-based fingerprinting. So this method involves comparing the hash of a malware to a database of known malware signatures to identify the specific type of malware the malware sample that we are testing on is. So in this case today we'll be testing on Lucky Cat, and let's get into it. So to perform malware fingerprinting, first we open up our VM. So this time it's Flare VM. And as you can see here, for convenience, I've also loaded the Lucky Cat folder here, which includes, double click on this. You see that it includes the application over here. Yep. So now, firstly, I will be going into the first tool that we'll be using today, which is under PE, and we'll be grabbing apologies, not PE. We'll need to go under utilities to look for WinMD5. So as previously mentioned before, WinMD5 is a tool that is used to uncover the hash of any sort of file. So today we'll be getting the signature or also the hash of the Lucky Cat malware. So here I drag the Lucky Cat malware into here, and we can see that WinMD5 immediately shows us a hash of the file. So hash starts with 9F9723, and this hash normally in malware fingerprinting, what we'll do is we'll copy this hash and we'll place it into another open source online tool called VirusTotal, which contains a signature a database of signatures of many malwares and also a lot of executables. So then we'll use this hash and compare to see what sort of malware this is. So for convenience sake, I've also loaded VirusTotal and added in the hash correctly. So over here we can see that actually the score on VirusTotal is 52 out of 71, so it means that 52 out of the 71 malware scanners have actually detected that this that files with this same hash that we've uncovered in WinMD5 actually is dangerous. So you can see here the security vendors have 52 security vendors have picked up that is likely a Trojan or password stealer, or it is generally just malicious and has malware. So that's it for the first page of VirusTotal. Perhaps if we look under the details, we can find out more. So details, it shows more basic properties like what's the MD5 hash of this which we can see over here, it's pretty much the same. 9F9 at the start and 8BL at the end. And for SHA-1, it is in this, and in SHA-256, this is the hash. So it can be seen in the history over here that it says the creation time of this malware file actually was in 2020 and it's first seen in the wild in 2019. And several other names of the same malware is credential.dll, win32.luckycat.exe, and several more file names. I think this one is the one that is being used in our folder here. Yep, so quite similar. So 8E9, E89 over here, and then goes on with a bunch of numbers. Yep. So it's also good to know that more information is provided on VirusTotal, and it's a very good resource. And as you can see over here under the Relations tab, it seems that several URLs are also picked up on, and also connected IP addresses. However, what is most interesting is that you can see here in the execution parent section, it seems that quite a few virus scanners have actually detected that the execution parent of Lucky Cat is a Office Open XML slideshow. So what this means is that in a lot of cases, this Lucky Cat malware is actually found within this Office Open XML slideshow, which is also a longer form for Office slideshows. So as you can see here, you can see that actually most of the time Lucky Cat is transported around using in the form of a Office slideshow and transmitted around using this file. Yep. So with that, we've completed a simple malware fingerprinting with WinMD5 and also VirusTotal. So now we'll be moving on to the next tool. So the next tool we'll be using is PEID. Here you see PEID has been opened. Let's close WinMD5 for now. So as you can see here, PEID over here is currently empty. So we'll be going into the file folder system and we'll be dragging out the malware into PEID. So as you can see for PEID, it started to load, and you can see that the EP section here, you can see the subsystem and also most importantly, the packer that was used to pack the malware. So over here you can see Borland Delphi. And if we are still skeptical whether this truly is the packer or the compiler, can click on this arrow here and can perform a hardcore scan. So hardcore scan, what it does is that it runs a more aggressive scan on the portable executable, and as you can see, there's no change in the results. So it's pretty much confirmed that this malware is using Borland Delphi as its hacker. So back again, if we do like a quick search on let's say any sort of search engine to search on what Borland Delphi is, it's actually a GUI IDE, and it is released for Windows. So as you can see, it's a pretty legitimate packer, so therefore we can tell that this is one of the signs that this portable executable is not a malware. So more ways on how to find whether the portable executable is a malware or not is to look at its EP section. So over here at the EP section, we see the .text. And if we click on the arrow at the side, it will show us the section view showing us the real size and the virtual size. So what this means is actually real size or actually raw size. Apologies, raw size denotes the size of the malware when it's stored on the disk, while virtual size refers to the size of the malware when it's stored on the memory. So usually when raw size and virtual size are somewhat similar, it means that it is not packed. However, if let's say the raw size is significantly more than the virtual size, we can tell that the malware is actually unpacked. And in cases where the virtual size is larger than the real size, then we can tell that a malware is actually packed. So why is this so? Is because packed malware compresses its code to a smaller raw size to evade detection most times. So if let's say the virtual size is more than the real size, it means that the malware is packed. So from PID, we have uncovered more details of the Lucky Cat malware. Firstly, it's of its packer, which is Borland Delphi, and we've also uncovered the fact that the malware is unpacked due to this its raw size being larger than the virtual size in most of its sections. Yeah. Alright. Moving on to the next tool. Next tool that we have in mind is PEView. So immediately after you open PEView, you are prompted to load in the file that you would like to see and display in PEView. So I select the Lucky Cat one on the desktop and the application. Since you can see a hex display of what the malware is supposed to be like is seen, and you can see the MZ at the side, which represents that it's a portable executable. So if you go under the image NT headers and expand this out to the image file header, you can see one very important detail that PEView is usually used for to view, which is the time date stamp. So over here it says that this what this time date stamp means is that on 2020 on 7th month and the 9th day at about on a Thursday, which at around perhaps 1 a.m. UTC time, this malware was actually created and it was actually packed. So that gives a very important time in terms of when a timeline is created on understanding what the malware or how the malware has been created. So for example, in the other sections, for example, as you can see here in other sections, there are no like there are no values mentioning on the time date stamp. However, if there were a section, there was like a description or any sort of variable that talks about the time date stamp, then you can piece them all together for each section and also figure out which section was created when this entire malware was created by the malware authors. Yeah. So in PEView, we've only gained one important new knowledge on the malware, which is that it is on this date, it is actually a important date as it is the date when it was actually Lucky Cat was compiled. Yeah. All right. So after PEView, we'll be using this next tool that is extremely useful called Dependency Walker. So as you can see, I'm starting up Dependency Walker. Just let it run. So in Dependency Walker, I go to the desktop and I run Win32 Lucky Cat. The application ended. So dependency walker is now opening the file. So what dependency walker does is that it actually it reads the malware file, and then after that it extracts out and displays out the dynamic link library files of the malware. So each dynamic link library file actually contains several two main things that we'll be looking at: imports and exports. So um, exports are functions that are that the uh, dynamic link library, or also known as DLLs, actually provide. So it exports all these functions out of its own code, and then it provides these functions that it has to other DLLs to reference or to use. Oh, seems like dependency walker is a bit slow today. So going back to the topic I was mentioning just now, also we'll find an import table and export table when we open up our dependency walker. And as previously mentioned, the export table is where all the functions that are exported out of the of each DLL, which allows other DLL to use, while the import is actually functions that are being used by the DLL by itself. Okay, so if you do receive an error over here, no worries, you can just exit out and you'll be in. So this is the interface of dependency walker. You can see here that there's a lot of red errors here and there. No worries. And also you can simply minimize all of these. It looks a bit scary at first, but if you're able to minimize all of these are all just simply sub DLLs that are under the one main big DLL. Okay, so now we have packed this, cleaned this up here. So you can see that there are actually 6 main DLLs for Lucky Cat's malware. So kernel 32, user 32, advepi 32, ole 32, SHL WAPI.dll, and WS232 DLL. So before we dive out and get our hands dirty in each of the DLLs, firstly, I just want to point you to this export function here, get object count. So what this means is actually to call upon the exe or to run it, you'll need to actually use this function, call upon this function, so that the rest of the DLLs are also mentioned and called upon. So we'll see this more in the basic dynamic analysis, where this function is used to run the malware, and also further later on in the advanced static analysis, where you can see the function in the IDA3. Okay, without further ado, let's dive into the first kernel, the first DLL, kernel 32. So as you can see, we'll look on the import table here. So there's several functions here of creating event, creating a file, creating processes, deleting a file, find first file exa, and find first file w. So there's several file related functions over here. So we can start to deduce that this malware actually has file manipulation and also file viewing capabilities. And if you scroll down a bit more on the import table, it also seems that there's a get computer name and get computer name W here. So these two seems to be also collecting information on the computer in respects to its computer name. So this might be a bit interesting. As we scroll down more, you can see that there's also more commands that and functions that are used to perhaps suggest that Lucky Cat is able to collect information on the victim's computer. So over here you can see get this free space. So it seems like this function will be getting the amount of uh, free space left on the disk along with the drive type. And as you can see, there's more file related functions. And as we scroll through, we do see quite a few functions here and there. Most of them are rather still quite generic in terms of its usage. It mostly helps the DLLs to run. Perhaps another interesting function of note is sleep. So sleep here is actually a function that is commonly used to pause a certain thread or process when it runs. So the reason why this is actually so important in terms of a malware's context is that sleep is used so that malwares actually stop their processes. And when they stop their processes, what it does is that it makes it so as if the malware is seemingly not being run on the victim's computer. And what this does is that malware detectors or any sort of like anti-malware scanners that may exist on the victim's computer will not be able to detect the malware. So that's why sleep is usually a quite common function when in terms of a malware. Yeah. So you can scroll down and see that we reached the end of the import table, with the last few being write file and write to console. So perhaps we might see some command line functions in the future. So it's also suggesting that Lucky Cat writes to the command line to perhaps execute certain commands. And at the bottom, we see some string length functions and string copy functions. So seems that there might also be some copying and finding out of length of the strings. So if we scroll down on the export table of kernel 32 DLL, it's mostly quite messy and it's referencing mostly all the, you can see some sub DLLs that are used and copy file, which throws back, relates back to the suggestion that Lucky Cat has file manipulation functionalities. And also see more file related functionalities. And that's pretty much it for kernel 32. There's actually quite a lot to look through here, but not all of them are actually important. So I think the most important ones have already been highlighted from the import table. So let's move on to user 32 DLL, which is the second DLL. So over here we have a printf, which essentially means to print, and also a character lower and character upper on the import table, and that's about it. So if we look down on the export table though, you can see quite a lot of normal Windows functions which are used usually to like support the processes in running or Windows in general to run. So not really too much here and there. So it seems that through the user 32 DLL, it might also possibly suggest that the Lucky Cat might be getting gaining more information of the victim or target's computers, like uh, settings and all, or just general information. So you see here there's a get window, desktop window. So there seems that Lucky Cat might possibly also have some uh, features that collects the data of uh, the victim's computer, and it also like uh, so you can see here also get keyboard state and get keyboard type also suggests that Lucky Cat might have some keylogger functionalities too. And it seems that most of the export functions here uh, can possibly be used by Lucky Cat to further understand and also to further help the attacker to know what sort of computer or device the victim device is. Ah, I also have seemed to missed out a function just now. So this one here, get async key state. Get async key state is actually a function that is commonly used to pull the state of a specific keyboard key that's being pressed. So this actually also contributes further that uh, perhaps Lucky Cat has key logging features and characteristics. So that's it for this section on the export table. However, if we scroll down to around where the eyes are, you can see here that there's inject keyboard input and inject mouse input and even pointer input. So as you can see here, it's also suggesting that Lucky Cat may have certain functionalities that may help the malware attacker to perhaps inject certain keyboard inputs or mouse input to control the computer. So I think that is quite an important point of that's from user32.dll. So the third DLL at webby 32.dll. So you can see here straight off the bat from the import table that there's a lot of registry related functions. So like registry close key, create key, open key, query value, and set value. So there's quite a lot of keys here that are registry keys that are possibly being edited for. So this actually suggests that Lucky Cat is actually a malware that also touches on the registry keys and edits them. So now we'll move on to the export section of adverb32. So you can see here, just a quick glance that under the A section that there's like audit lookups and queries and also audit set global. So seems like Lucky Cat is also able to possibly have uh, audit looking and lookup and query and also setting of global settings and policies within the victim's machine. And apart from that, you can also see under, if we scroll down even more, that you can see here that it's also seeing, we see a lot of crypt, which also may be referring to cryptography. So as you can see, there's crypt decrypt, there's also crypt encrypt. So perhaps what Lucky Cat may have, or may have a functionality that encrypts or decrypts maybe perhaps files or registry keys so that they are unable to be seen or edited. So it is quite an interesting feature. So another interesting one is actually CVE event write function. So what this function does is it actually pushes out a Windows log when an attempted security vulnerability exploit has actually been found within the um victim's device. So with this with this function here, perhaps what Lucky Cat may be doing is that it suppresses this function. So every time the CVE event write detects that the Lucky Cat malware is being run on the victim's computer, it could possibly Lucky Cat could possibly be suppressing the output of this function on purpose, and so that it can maintain persistence. This is the same as previously we saw the sleep function too. The sleep function is also used to evade detection and also uh, evade from alerting authorized personnel to mitigate these issues. Yeah. So these functions are just to simply maintain the persistence on the victim's computer. However, it's a quite interesting find too, as it shows the defensive practices that are possibly taken by the malware so as to maintain uh, persistence on the victim's computer or device. So next up, we go into the OLE 32 DLL. So the first thing we see in the import table is co-create GUID, and we actually will go further into that in with this in the advanced static analysis, as this function is talking about creating a global unique identifier so that a globally unique identifier so that it's easy for um so that it's easily referenced once this GUID is created in the future, and uh, it's also easily identifiable. So now let's explore the export table of only 32. You can see several stuff. So once we get down to around the O section, we can see only create from link, create link to file. These are all actually, with all these functions here, it means that and all these function actually like permits the creation of embedded files or objects through the clipboard. So what it does is that it allows duplication of data from one file to another. So and uh, it's also a possible tool that the malware Lucky Cat is actually using, as at sometimes uh, a lot of commonly malwares like to common behavior is like they like to copy the original malicious code from a remote network location onto the local computer. So all these sort of behaviors of copying the malicious code, perhaps the source code from the actual uh, perhaps is hidden in a document, so it or embedded within a document. So this malicious code is then copied and run within the victim or target's computer, which causes the victim's computer to be compromised. So that's one thing interesting about the early 32 DLL. So on the second last DLL, we see several string comparisons and copying of strings here in the import table. And if, let's say, we look more on the export table, there are quite a few. You can see here it's not a typical DLL. As you can see previously, we see a lot of function names. However, in this DLL, there is a lot of NA function names, like not applicable function names. However, we can see their entry point. So it's definitely refreshing. You can see here that once again, we see creation of files from the kernel 32 DLL that we previously saw. And we also see like things like the printf from the user 32 and many more over here. Oh, so just nice. The glitch has allowed us to scroll down further onto the export table and actually reach the place that we're looking at. So you can see over here there's a shell 32 and then shell get file info, and we can get a shell 32 drag query file. And if you scroll down further, you can see further shell 32. So what this does is referencing to the command prompt or the command line that is within the Windows, and it's actually referring to this, the command prompt. So the command prompt on any sort of Windows machine can actually be used to run the malware, or it can be actually used to navigate into like browse directories and also look for files and folders within the file system of Windows. So it's actually quite important because the malware may possibly be using these functions so that it's able to navigate the directories of the file systems that the target computer has. So lastly, and most importantly too, also, we go into the last DLL here that says, which has actually two imports here, free address info and get address info. So these two are actually used for IP address resolution, which helps to resolve, let's say, a human readable URL to a machine or computer device readable and understandable network location that it can direct the user and connect the user to. And furthermore, over here in the export table, we can see several more functions. So WS2 actually stands for Windows Sockets 2, and what a socket does is simply to create an endpoint for a two-way for like a two-way communication over the internet to occur. So as you can see over here, it will actually, this socket will set up a remote connection to the network location set specified. Yeah. So you can see here connect perhaps, and then accept function. What does is that it accepts data from the remote location. And if you scroll down more, you can see also the socket function and several free address info, get address info, which does the IP address name resolution. And that's pretty much it about the Windows socket. So as you can see from dependency walker, it's actually a very useful and powerful tool that we managed to uncover several possible functionalities of Lucky Cat. So we'll now move on to our last tool that's used for static analysis, which is called bin tags. So here we start up bin tags. So it's a very small interface, so I'll try to make this a bit larger. And I will then drag the malware into bin tags. So now in bin tags, we can see that the Lucky Cat has actually been opened and the strings have been extracted from it. So if we do a very quick scroll through, because most of these tags here are pretty much junk, and you can see that there's quite a bit of junk here and there. See the days of the week and the months, and the malware itself loading the alphabet. After that, we start to see more names, function names, like get system time as a precise file. And if you scroll down here, you can see that the DLL is then starting to connect to W, S, and then D. So what this might possibly suggest is that the DLL might be starting to connect to a WebSocket or a web service. So you can see that the DLL has really taken initiative to contact a remote network location. So might be possibly contacting the remote network location to perhaps get into contact with the malware authors or the attackers. Or perhaps it might be copying a file from the remote location to copy it into the local victim computer. So now that we've scrolled down, you can see here there are more functions also. So you see firstly credential.dll, which if you do remember from our virus total scan, it is actually a suggested other name of the file. So we know that credential.dll means Lucky Cat malware. So this malware is so with this string we can see that the malware is probably run, and then the first export function is then seen, the get object count, and after that we can see that there's a string len, output debug string, which are functions also here are being run, followed by the sleep function. So then there's also furthermore functions that have been seen in the analysis in dependency walker. Remember the registry queries and registry function related functions, and we do see the co-create GUID also here, and a lot of repeated imports and exports in here. So if we scroll past this section here, you can see more junk text. So our goal from bin text is to extract out more interesting strings here. So as you can see, we've reached a section where once again there's a bit more interesting information. So over here is adverb v32, which references the DLL adverb v32 that we've seen in dependency walker. And these two here are also sub DLLs that are contained in the main DLLs to help Windows to function. And then we do find a DLL that we have actually not seen within dependency walker previously, msscoree.dll. However, a quick search online on what this DLL is actually, it states that there's an essential file for execution of managed code. So it's actually vital for Windows to run on, so that's why this DLL is here. So it's also suggested that this DLL is used to help out in the running of Lucky Cat, the Lucky Cat malware or any sort of executable file that's run on Windows. And hence over here, you can see more sub-DLLs that are mentioned, and a lot of trash or ununderstandable text here. So we quickly scroll past through it. And over here, we do see that towards the end of all these nonsense strings, we do see this URL look like thing here, Dalai Lama trustindia.ddns.net to port 110, and another one to port 443. So port 110 is to the POP3 protocol, which is an email transfer protocol, and 443 is for HTTPS, which is for loading websites. And lastly, over here, we see another possible IP address, 115.126.6.16, and at the port 110, which is port 3 protocol once again. Yep. So if we scroll down here, also, we do find this thing called Windows Credential Manager. Does not seem like anything much, but we'll be going through more of it in the dynamic and also in the advanced static analysis. And once again, once we scroll down, we can see that this program cannot be run in the DOS mode. So this means that the strings are starting to repeat again, and the same exact strings will be repeated as following below. So that's the end of syntax analysis of the strings for the malware. So that's about it on the basic static analysis. So if we go back straight to our sites, so just now in the tools used, we've managed to use WinMD5. We've also managed to use PID and PView to uncover the details like the packer and also whether the malware is packed or not packed, and whether when the portable executable or the malware is also compiled at what time it is. Through PEview and through Dependency Walker, we've also managed to pick up several possible functionalities of Lucky Cat. And lastly, in Bintext, we can also see there are actually several URLs that the DLL is possibly trying to connect to through the WebSockets or the WebSocket a DLL. Yeah. So with that, that's it for the basic static analysis. Thank you for listening to this.